Good morning, students. Today we will discuss about this EF CODD rules. Right. So first of all, who is the EF CODD? The person who developed the relational database model. Relational data model who developed is called as what? EF CODD. Is a computer scientist who worked in the IBM as a database architecture. The person who developed this relational data model. So for the database management system, he developed some rules to work on a database. Totally 12 rules he developed, which is used to test the database is perfectly or not. Okay, how the normalization will be used to test the table is a good or not. Like that, if any database is a good or not, that need to satisfy the rules of EF CODD, right? So CODD rules actually define what quality of a DBMS requires in order to become a relational database management system. So it checks the quality of the database, how it reaches to this customer knowledge or customer level. So that will be checked by using EF CODD rules. Totally he composed the 12 rules for the testing of DBMS concept. Okay, so now we'll see one by one what are the rules are there. Okay, so first rule, there is no zero rules sir, but some of the people they are saying about zero rule. This rule states that for a system qualify as an DBMS, it must be able to manage database entirely through the relational capabilities, right? Checks this qualification of qualify of RDBMS. For that, they developed one is that called as a rule 0. Then what is the rule 1? Information rule. So what is the information rule? The information rule is gathering the information how what the customer required. That is the first rule, right? All information, including metadata, is to be represented as a stored data in cells of tables. The rows and columns have to be strictly unordered. Okay, so what type of information they require, whether this information will be possible to store in the form of rows and columns, that will be checked by using information rule. Next one is guaranteed access. What is the meaning of guaranteed access? So the atomic values, whether we can read the values or not, right? So how to access, what is the guaranteed access? Suppose giving the permissions means how we can retrieve the information from multiple tables by depending on primary key and foreign key, right? So that will be checked by using guaranteed access. Second ones, each unique piece of data atomic value should be accessible by table name plus primary key, that is a row plus attribute column. So note, ability to directly access via pointer is a violation of this rule. Okay, it need to depend on table name plus primary key plus attribute, that is a column name. Okay, so that is the guaranteed access. Next one is what? Systematic treatment of null values. So as already you discussed about the null, suppose if not be possible to enter the value, then we can represent as what? Null. That we need to follow, that we need to control the null values, where we can give, where we can't give. So that we can systematically we need to follow the rule for null values. And null has several meanings. It can mean missing data or not applicable or no value, right? Missing data or not applicable or no value. So missing data means while entering we don't know the value. Okay, so then we can go for missing data, or at that moment we should not enter the value, then not applicable means there is no value for that, then we can go for the no value. It should be handled consistently. Also primary key must not be null ever. Expression on null must be given null only. Suppose any calculations are there, what is that? Example, total, average, we need to calculate. Age, we need to calculate, right? At that moment it is not possible, we know that there is a value, but right now we can't enter that value, that we need to properly maintain by using null data type. Then active online catalog. So what is the online catalog? The database security or database dictionary, right, is the structured description of the complete database, and it must be stored in online. The complete structure of the database, the complete structure of the database, that the catalog must be governed by some rules as rest of the database. The same query language should be used in catalog as used to the query database. Whatever the query used to develop the database, same database we need to use for database dictionary also. So that is called as a data dictionary, also be called as what? Data catalog. What data dictionary contain? the entire structure of the database. Entire structure of the database. Okay. Then rule 5 is what? Powerful and well structured language. So to develop the database language, we need to use a powerful language, a perfect language, right? Suppose a customer required more database, but used a very less language, then the mismatch will be there. So to avoid that mismatch, we need to go with this well structured language we need to use. Okay, so one well structured language must be there to provide all manners of access to the data stored in database. Example, SQL, MySQL. Like this, we are having the different type of the languages. If the database allows access to the data without the use of this language, then the data is violation. Right? Suppose you want to use the more relations, but we can't be work with MS Access. At that moment, there is a mismatch will be there. To avoid that, we need to use the well-structured languages. Next one is what? View updation rules. Right? In the theoretically, update should be updatable by the system as well. Frequently, the data should be updated. The data should be updated in all the areas. So that is called as what? View updation rule. Next, what is the rule 7? Relational level operation. What is the relational level operation? There must be insert, delete, update operations at each level of relations. So what should be there in the relations? Insert, delete and update operations need to done. Set operation like as union, intersection and minus should be also be supported. So all the operations need to support. Then that is called as what? Relational level operation. Right? So all types of operations. It may be insert, it may be delete, it may be update, it may be union, it may be intersection, it may be minus. Okay. So what is this next one? Physical data independence. So physical storage of data should not matter to the system. It say some file supporting table is renamed or moved from one disk to another. It should not affect the application. If suppose any file is depending, if that file is moved from one place to another place, unfortunately that file is moved, but this should not be effect. That should not be effect. So then the type of the thing is called as what? Physical data independence. Suppose think that one take an example in the real life also. Suppose you are using or you are coming to the college. You are coming on your bike. Suppose suddenly the bike is not working. So what you will do? We will go with this mechanic or we will keep other side and we will come to the college with some other way. Means that should not be effect. Like that, the physical data independence also. If the file is depending on that one, even if it is moved also, it should not be affect the original application. That is called as what? Physical data independence. And logical data independence. So the structures, table structures do not be affect. Right? It should be properly worked on this one. Then that is called as what? Logical data independence. If there is a change in the logical structure or table structure or the database, the user view of data should not change. If even if any changes have been occurred, there also not be changes in the user view level. If a table is split into two tables, a new view should give results as the join of the two tables. This rule must difficult to satisfy. Right? So if table is split into two tables also, if you retain information, the data should not be affected. So that is called as what? Logical data independence. And what is the 10th rule? Integrity independence. What are the integrity rules? Integrity rules nothing but check, constraint, null, not null, unique, these type of triggers. So these type of this integrity constraints need to work on the RDBMS or database, right? So the database should be able to enforce its own integrity rather than using other programs. Key constraints and check constraints, triggers, etc. Primary key, foreign key, candidate key, super key, composite key. These are the key constraints. And check constraints, trigger constraints should be stored in data dictionary. This is also make RDBMS independent or front end. Next one is what? Distribution independence. What is the distribution independence? A database should work properly regardless of its distribution across a network. Right? A database should work properly regardless of its distribution across a network. Distribution independence means suppose if a database is stored in a server that need to use by all the members. For example, you are looking for your results. The data will not be available on every system. The data will be available on one area that we need to share. So that is called as what? Distribution independence. The data need to distribute it. Okay, anyone can access that information. It not be restricted to only for few people. Be restricted. It will be given to all the members, right? So geographically, the data need to distribute. Then that is called as what? Distribution independence. Check it once. What is there? A database should work properly regardless of its distribution across a network. Even if a database is geographically distributed with data stored in pieces, the end user should get an impression that it is stored at the same place. Even if it is in the pieces also, the data should be come in proper. Okay, this lays the foundation of distributed databases. Okay, now last one, what is that? Non-subversion rule. What is a non-subversion rule? If any upgradation is there, low level to high level, right, it should not be affect the original information. If low level access is allowed to a system, it should not be able to subvert or bypass integrity rules to change the data, right? The data should not be affected. Then that is called as what? Non-subversion rule, right? This can be achieved by some sort of looking or encryption. Okay, so there is a non-subversion rule. Means what? The low level data to high level, the data should not be affected. Any key constants or any constant should not be affected if the data is converting or if the data is accessing at the low level, from low level to high level. Okay, so these are the rules for EF CODD. What are the rules are there? Once again, we'll see. The first one is information rule. Second one is guaranteed access. Third one is systematic treatment of null. Fourth one is active online catalog. Fifth one is powerful and well structured language. Sixth one, view updation rule. Seventh one, relational level operation. Eighth one, physical data independence. Ninth one, logical data independence. 10th one, integrity independence. 11th one, distribution independence. And 12th one is what? Non-subversion rule, right? So this is, do the more practice. This is one of another important question in the first unit. EF CODD rules. Total 12 rules are there, and some member they can say as a 13. That's a 0 will be rule 0. Okay, right? Thank you.